Hello everyone, in this video we will learn how to perform a star-delta transformation. Let's take a look at the circuit in front of us. No matter which method we choose to solve it, we might get a different solution. However, if we choose to use a Y-delta transformation, we will reach the same solution regardless of where we start. Here we can see 4 possible delta options. I always prefer to start from the furthest point and simplify towards the source. On the right, in orange, you can see how to draw a star circuit. Now that we've chosen the delta and drawn the star, let's label the resistors. The resistor between R1 and R2 will be called R1.2. The resistor between R2 and R3 will be called R2.3. And the resistor between R3 and R1 will be called R3.1. This is how the formula works. The star resistor is equal to the product of the adjacent neighbors divided by the sum of all delta resistors. R-2 equals R1 times R2. And all of this is divided by R1 plus R2 plus R3. And so it continues. R2.3 equals R2 times R3. And all of this is divided by R1 plus R2 plus R3. R3.1 equals R3 times R1. And all of this is divided by R1 plus R2 plus R3. Time to draw a new circuit. In the new circuit, we see R4 in series with R1.2. We also see R5 in series with R3.1. Let's simplify them and see what we got. Notice that R8, R7, and R6 form a delta. For those who are ready, you should pause the video and try to solve it first. R6.7 equals R7 times R6. And all of this is divided by R8 plus R7 plus R6. R7.8 equals R8 times R7. And all of this is divided by R8 plus R7 plus R6. R8.6 equals R6 times R8. And all of this is divided by R8 plus R7 plus R6. After drawing the new circuit, we see that resistors R2.3 and R6.7 are in series. Let's connect them and see what we got. Since we've converted enough deltas, let's also convert one star. We see that resistors R8.6, R7.8, and R7.2 form a star. Let's see how to convert the star to a delta. Each delta resistor sees the 2 star resistors on its sides. For example, the resistor marked 7-2 sees R6.7.2 and R7.8 on its sides. To avoid writing R7.8672, we will simply shorten it. We will call it the resistor from 7 to 2, or R7-2 in mathematical terms. This is how the formula works. A delta resistor equals the sum of the products of neighbors divided by the opposite side of the delta resistor. For example, R7.2 equals R7.8 times R7.2. Then R8.6 times R7.8. Then R6.7.2 times R8.6. After multiplying the neighbors, we will add them into one general resistor, and only then divide by the opposite resistor. We will repeat the process for each delta resistor. We've reached a state where it's not so easy to understand the circuit before us. Therefore, we will learn a method that will help us in many exercises. I marked all the nodes in the circuit as A, B, and C. Then we draw the paths from node to node and list the resistors, resulting in a clearer circuit. Here you can see what is really happening in the circuit. We have resistors R8.2 in parallel with R1.4. And we also have resistors R7.2 in parallel with R3.5. And of course, you can see they are in series. We are left with a parallel circuit with 2 resistors. We will use the formula for parallel resistors. We found the total resistance is 0.78 ohms, and its name is R total. Now we can find the total current. I equals U divided by R. We found the total current of the circuit is 6.345 amperes. And the name of this current is I totals. Thank you for being with me until the end. Please leave a like if you enjoyed it. See you in the next video.